In the previous episode, we discussed Kubernetes X509 client certificate-based authentication. We also walked through the process of how we can generate client certificates for our users. Let's walk through that process very quickly again and also point out some of the issues that are associated with this method. First, from the Kubernetes admins, they create a new cluster. As part of that cluster, a new PKI infrastructure is also set up. And that PKI is responsible for managing all the certificates that are used internally within the Kubernetes itself, such as the client certificates that are used by a control manager, scheduler, or kubelet that they need to talk to the API server. It also manages all the certificates that are needed to generate certificate for SSL, that is for encrypting. Admins can also use the same PKI infrastructure to request certificates for new users. Let's walk through that process quickly. The first thing that they need to do is they need to generate a private key for the certificate, then generate what is known as certificate signing request or CSR. And in that, they will specify the username, in this case, Jane Doe, CN equal to, that's common name equal to, and then able to use as Jane Doe. And then they can optionally also specify the group or groups that the user belongs to, /O, that is organizational unit. In this case, we are assigning Jane Doe to the marketing lead group. They will then need to encrypt or encode that CSR in base 64. And then they will need to submit that CSR to the API server. Next, they will need to approve the CSR, and they have 1 hour to do so. And finally, they can retrieve the certificate for the client. And this is a certificate that some of the more important parts of the certificate are shown here, such as serial number, which is unique for each certificate, and also the algorithm that is used to sign the certificate, the issuer name, in this case is the Kubernetes itself, the PKI infrastructure, and also the expiration dates. So by default, the client certificates are expired after a year and needs to be renewed. And finally, we have the subject that we discussed earlier. So although this works pretty well in a small environment, there are some issues with this method of authentication managing users. The first one is certificate cannot be revoked. Let's say Jane moved to a different area within the organization and she no longer will be needing access to the Kubernetes. But there's no way for the Kubernetes admins to revoke that certificate. The only thing they can do is they go to inside Kubernetes and use authorization, RBAC, to remove Jane's access to the components that she has access to, such as pods, secrets, and so on. And as you can see, this will take a lot of time, especially if there are many users that are moving around. So in a larger organization, this is will be cumbersome. Also, when the user is assigned to a group in a certificate such as this one here, again, there is no way to change the group. For instance, Jane may be still needing access to Kubernetes, but she's moving, let's say, from marketing to a different organization, such, let's say, accounting. But the certificate already has been issued. So the only thing that the admin can do is create a new certificate for Jane. And now Jane, again, and remember that certificate cannot be revoked. So Jane will have now two certificates. One will give her access to the marketing artifacts, and the other one to the new accounting environment. So again, this is another issue of managing groups in using certificate is difficult and creates security issues and also overhead for our administrators. And finally, creating again as you saw, the number of steps required to generate certificate for a user. Again, this is not a big deal if you have a small environment, but as you have hundreds, maybe thousands of users, then that becomes an issue. And also these certificates will need to be renewed annually. And again, that's an overhead. So for this reason, Kubernetes enable administrators to delegate managing users and groups to external systems. And one of those external systems is OpenID Connect that we will be talking about today. There's another option. You can also manage, you can integrate directory services such as Microsoft Active Directory or Linux-based services or systems into Kubernetes. But today's talk we'll be discussing OpenID, how it works. And one of the really nice features of using OpenID Connect is it can be used for single sign-on, not only by Kubernetes, we can also use it by other applications in your organizations. So what exactly is OpenID Connect or OIDC for short? OpenID Connect or OIDC is an identity protocol that is based on OAuth 2.0 and provides user authentication and the ability to store and provide information about users, also known as claims, in the form of ID token. And the ID tokens format is Java Web Token or JWT. So in other words, OpenID Connect provides new functionality on top of OAuth 2. So it does not replace OAuth 2. So don't be confused. It simply extends OAuth 2. It provides modules that provide authentication and user management features. So there are a number of components and terminology in OpenID that you should be aware of. The first one is OpenID Provider. This is basically the authorization server that authenticates the users and issues the ID token. So there are many OpenID providers currently in existence, such as cloud-based, such as Microsoft Azure Directory Services or Google Directory Services, Amazon, so on. In this course, in this video, we will be using a provider called Okta, OKTA. End user, the end user's information that is contained in the ID token. Relying party, the client application that requests the ID token from the OpenID provider. In our use case, Kubernetes, and to be more precise, kubectl is the relying party. ID token, the token issued by OpenID provider and contains information about end user in the form of claims. And claims basically are things such as user ID, groups that the user belongs to, email address, and so on. So let's walk through the OIDC authentication workflow involving Kubernetes. So let's say we have a Kubernetes environment, a cluster. We also have access to an OpenID Connect provider. And let's say we have an end user, a Kubernetes user called Jane Doe, who wants to communicate with the Kubernetes cluster. So this is her laptop, which has kubectl. This is obviously essential. This is how we communicate to the API server to kubectl. She also needs a new component called Kubelogin, and that facilitates authenticating against the OIDC provider. During the demo, we'll talk about that, how you can get that installed on your workstation. Let's say Jane now wants to send a query to the Kubernetes API server, kubectl, for instance, get pods minus and marketing. So she wants to list all the pods in the marketing namespace. So the request goes to kubectl, and then that is intercepted by the Kubelogin. So Kubelogin opens the browser on her machine and navigates to the the OIDC provider login page. In this case, we are using Okta, so then Jane will need to provide her user ID and password, which is then sent to the authorization server, which upon authenticating to ensure that the user ID and password are correct, if that is the case, then it issues a token called Auth or the authentication token, which is sent back to the browser, which finally sends back to the Kubelogin. Now Kubelogin takes that Auth token and makes a call directly, not through the browser, but directly to the OIDC provider and requests for what is known as access token. Access token is another token which includes the ID token. Again, ID token has information about the user. Now you may be wondering why it makes two calls, first for auth code, authentication code, and then second one with access token. So this is for security purposes because browsers are not inherently secure. And in order to get the access token, the Kubelogin will need to share a secret. It needs to send a secret to the OIDC server. And doing that through the browser is not very secure. It can be done for situations where browser appropriate, these two can be combined, but usually it's more secure to do it this way. And this is how it's implemented with kubectl. So again, the ID token is also called bearer token, is in JOT or Java Web Token format, and it has claims or information about the user, such as the user's login information and the groups that she belongs to. And it is also, very importantly, is signed by OIDC provider. So that is sent back to Kubelogin, which is sent then to kubectl. Now kubectl has everything it needs to send a request to the API server. It will use the access token as a header. This is called authorization header. And so that sends the request and the authorization header to the API server. API server then peeks inside the ID token. The first thing that it does, it ensures that it is signed. The signer, in this case the OIDC, is trusted. So to ensure that this is valid and trusted. The next thing that it then does is it'll take a look at the query and sees that the information or operation that the user is doing on this the component, in Kubernetes component, in this case pods, she has access, adequate access to them. So she will do that through authorization module and RBAC, or role-based access control, and checks to see if the user, Jane Doe, or the group, one of the groups that she belongs to, either one of those, has appropriate access to the component or the artifact in the Kubernetes that she wants to operate on. If that's the case, assuming it's okay, then the results are sent back to the client. So this is how kind of the whole workflow. So demo is coming up soon, but let's talk about the prerequisites that are needed and also the process, what we will be doing in this demo. So the first thing that we need, obviously we need an OpenID provider. For this, we'll be using Okta. The nice thing about Okta is it offers free developer account. We will also we'll need to install a component, a Kubernetes plugin manager for kubectl called Crew. And then we will use Crew to install another component called OIDC login, also known as Kubelogin, to facilitate the login process that we talked about earlier. We will also be using Terraform. So Terraform is an infrastructure as a code tool, so you need to install the client on your machine. This will assist us in configuring Okta and also creating our users and groups inside Okta. You don't have to use Terraform. You can use Okta's web page, but obviously it's better to automate everything. So especially during the development and learning, you don't want to just go back to the GUI and create this. So you want a way to automate this, setting up and tearing down your environment. So I highly recommend using Terraform. On the Okta side, we need to set up what is known as authorization server. And there are two components involved here. One is Okta application integration. This basically provides the login facility to clients can log into, and also it manages the users and groups. We also need another one called Okta Authorization Server, and this manages all the tokens. So the combination of these two is really the authorization server. On the user side, you will be creating 3 users: Terry Jones, John Doe, and Jane Doe. We will also creating a number of Okta groups and assigning our users to it. The first one is K8S-marketing devs, and we add Terry Jones to that. The next one will be K8S marketing DevOps, and we'll add John Doe to it. And finally, we create K8S marketing admins, and we'll add Jane to it. So these will be our users and groups that will be then using Kubernetes to provide access to and use them for our authorization purposes. Okay, now that we have created our users and groups in Okta, we can bind them to our roles or cluster roles in Kubernetes. So to start off, we are going to bind K8S-marketing-admins. We're going to bind it to a cluster role called admin. This is a built-in cluster role called admin. However, the scope, we need to set it to a specific namespace, and we're going to set that to marketing namespace. So basically, the members of this group, we will have admin rights to the marketing namespace. In a larger organization, if you have a lot of resource, a lot of people and projects, then maybe it would make sense to delegate some of those to other team members. And then we will also then bind K8S-marketing-devs. We're going to create a new cluster role called DevOps, but again, the scope would be in the marketing namespace. And we're going to assign these resources. They will be we'll be able to operate this on these resources that are listed here. And these are the type of operations that they can do on. So basically, below the administrators, then you have the DevOps that have access to quite a bit of items in Kubernetes. And finally, the developers, we're going to assign these resources. We allow them to operate these resources. So for pods, we're going to allow them to do get, list, watch, and delete. And for other ones, we are going to assign them get, list, watch. So again, the scope of this would be in the marketing namespace, not at the global level. So next, we're going to take a look at how you can sign up for Okta for your developer edition, and also show you what Okta website looks like and how we can create users and applications. Again, if you don't want to use Terraform, which I highly recommend, you can do it through the GUI as well. To create a free developer's account, you can come to https://developer.okta.com/signup, and I'll provide a link in the video's description. Once you're here, then you can create an account, put in your email address, username, the region that you come from, etc. There's an easier way. If you have a GitHub or Google account, you can click on either of these two tabs, and then it will take you to its respective login page. Once you log in, Okta will get information from either one of these two sources about you and create an account automatically. Anyway, once you create the account and you log in, this is what you'll see. There's a lot of stuff in here that we don't really need for this course. Let's just concentrate on what we need to know about this course. So look under people, this is where your users are. So when you create new users, either manually or through Terraform, then they will show up here. Over here, you can create a new user manually, reset password, and so on. You can delete the user and so on. Under groups, you can also create groups that your login or your user will be belonging to. You can again add a group manually or do it through Terraform. So again, Terraform is preferred because then you can automatically create and recreate your user, especially when you're learning. We also talk about Okta application. When you click on their application, so these are kind of already built accounts. We will be creating one new one, and that application will be used for integrating Kubernetes into Okta. So we talked about that earlier in the presentation part. We also under security. So this will be responsible for showing you when the user logs in and tries to access Kubernetes. This is kind of managed here. It also manages the users. Under security and API, at the last bottom here, this is where we create the authorization server. So again, when we run the Terraform scripts, next step, then a new application or new authorization server will be added here. So again, authorization server is responsible for managing tokens for the users. So before getting to the next step, a couple of things that you need to do. First, click on tokens, and you need to create a new token. So this token will be used for Terraform to log into Okta and create everything from users to authorization server. So basically this will be the password. So create a new, whatever you can call it, whatever you want, and create a token. And then this, you need to take note of this. So copy that to clipboard because you need that later on for running the scripts, Okta script. So copy that. Also, you need to know your account. And this is basically your account. Click under your login information here. And again, take a note of that. So copy that to clipboard. So this is what we need. So this is the user ID, and that will be the token will be the password that Terraform will be using to automatically log into Okta and create artifacts for our integration with Kubernetes. Next, we're going to Visual Studio Code and actually walk through the process. So before going any further, I want to draw your attention to one issue that I've run in with Okta. So if you access the Okta admin page from a machine, and you try then to run the script that we go through next, and you want to impersonate a user that is logging as a different user, such as John Doe or Jane Doe, then it'll throw in a HTTP 400 error. I think the reason for that is it still remembers the claims that generated when you logged into as admin to the Okta page, Okta site. So my advice is I strongly suggest that you access the Okta admin page from a different machine, and then you can use a different machine as your client, and then you can do impersonation. You can log in as whoever you want as the new users as you create them. That is also true if you want to switch between users. You won't get the error. However, it's difficult to switch from one user to user. So if you have 3 users and you have 3 machines, it's easier if you have like a 3 different machine that you can log in as a different user. And the reason for this is that these tokens are long living. So you can just play with one user on one machine, that's fine. And it's really the same thing. You don't need to impersonate everybody. So it's kind of, I wanted to draw your attention before moving any further. Okay, first let's discuss the prerequisite, what we need on the client. The first thing that we need is crew. As we mentioned, crew is a plugin manager for kubectl. So if you are on Linux, this is how you install that. Linux or Mac, this is how you install that on your machine. On Windows, you need to go to this URL and download that and install it. So that is crew. Now you also need Terraform, and that is basically infrastructure as a service. On Linux, this is how you install it. On Mac, this is how you install it. And on Windows, this is how you need to get it again from this URL and download that. So once you have your prerequisite installed, again, everything is on the client. You don't need any plugin on the servers. It's all on your client. Then we need to create Okta scripts. So there are we need 3 files. One is called okta.main.tf. The other one is called, this is the main script. And then the next one is okta.config.auto.tf-bars. And this is basically information about your URL, your account. Recall that I told you to copy the URL of your developer account on Okta. This is where you put it. So org name would be the dev dash and the number. So that would be the that part of the URL. And then the base URL is okta.com. And then secret.auto.tf vars. This is the token that I asked you to create in the previous example. So Terraform will be using this login, which is basically your developer's account URL. And this is the password, would be the token, the API token that you created earlier. And then this is the main kind of meat of the Terraform. So first, we'll define the variables called base, org, and API token. So these are all taken from these 2 files. So those are automatically grabbed from those 2 files. And then these are boilerplate information. It's like Terraform. You don't need to make any changes here. So this is a version of Terraform that we'll be using. And again, you need to leave, and this will be reading again the variables like org name, base URL, and API token from the file that we talked about here. And then in the next section, this is where we define our users. So the first one is resource. So these are all Terraform lingo. Okta_user, so that would be Okta user, and then the name of the user that you want to create, and I call this, the first one, admin. The first name, you need to specify the first name, last name, so admin, in this case admin, and the email account, and the login, again, is the same as email account. And you need, optionally, you can specify a password for the user. In production, in real world, you won't be setting the user password in the script. Leave it as is, leave the status as status. And once the scripts are run, Okta automatically sends an email to whatever email account you specify for the user, and will invite the user to go to Okta and will create an account there and set the password there. And then we also create another account. This one is, the resource is Okta user, Okta_group. So basically an Okta group, and I call the K8S admin. So these are the admins at the cluster level. So we create that group, And then in the next section, we bind the user to that. We add basically the user to the group. So the resource is Okta underscore user underscore group underscore memberships. And then we give it a name. I called it admin, KS. So this is the admin, KS admin. And then the user ID, this would be the admin, the name, the ID of the user that we created earlier. And the groups, this is the group that we created earlier. So basically, we are binding the users to the group, or we are adding the users to the group. And we do the same thing for Jane Doe. So again, these are user information. And then this is K8S marketing admins that we talked about in the presentation section. And then this is the name. And then again, we add Jane to that group that we just creating. So basically, Jane will be a member of KS marketing admins. So this is the that part. And similarly, we create a user John Doe, and we add John Doe to KS marketing DevOps. So that would be the group that he'll be belonging to. And finally, last user is Terry Jones, and we'll be adding Terry to K8S-marketing.devs. So these are our users then. And then the next section will create an OIDC application. We give it a name. We call this K8S OIDC. So when we create this and we go back to the admin, Okta admin page that I showed earlier, then you'll see a new user or a new application with that label will be created. And we said the type has to be native. And then these are all, again, boilerplate. So when the user needs to be authenticated, the login page, the login, kubectl login will run or will start the process, a server on port 8000. And from there, it forwards the user to the actual login page of Okta. So this is what it is. And then the next section, we create, assign the group that we created earlier. They need to be added to the OIDC application. So the resource here is Okta underscore app underscore group underscore assignments. And then this is the assignment group, K8S OIDC group. And then this is the name of a group that will be created. And then we add all of the groups that we created, like admin, marketing admins, and marketing DevOps, and marketing or devs, and marketing DevOps. All those will be added to OIDC application. This is necessary, otherwise they won't be able to log in to the Okta. And then this is the output. So once the script is run, it will print out the OIDC client ID. So we'll have that client ID. I'll show you once it's completed. So this would be one output after this is run, the script is run. And then we also need to create the authorization server. Again, that would be managed on port 8000, will be forwarded from there to the authorization server. And this is the output that will create. So it would be the second output when this is run. That would be the URL that will point out, that prints out. And that is what the user will be using in the config file in order to, and also in the Kubernetes config page or Kubernetes configuration file. So Kubernetes knows about where to send the user for authentication. So that would be the second output. We also create or specify what kind of claim, what kind of user information will be sent once the user is logged in. And the information that we want to send with is groups. The last one is type. So all the groups that the user belongs and the value any group that starts with K8S dash. So you remember all our groups that we created start with K8S. So if a user belongs to one or more of those groups, then those will be sent as part of the header or the tokens that they send back as claims, and that's where Kubernetes knows what groups the user belongs to. And finally, a couple of sections here for policy and rules. So just basically don't do anything, just copy and paste them and use them. You don't need to make any changes. It's basically whitelisting application access to the authorization server. And over here, optionally, you can set the token time, lifetime. So you leave that as is. By default, it's valid for an hour before the user needs to log in again. So this is basically the first section of kind of walking through what needs to be done and looking at the Okta file. Okay, now let's go ahead and actually execute this. So the first thing that we need to do is on line 2, Terraform init. So the first one, you need to initialize Terraform. And then, so let's go ahead and do that. And you'll see that it was successfully initialized. And then on line 3, Terraform plan -auth equal to Okta _plan. So basically, what it does is compiles the main.tf and to make sure that everything is okay and there are no errors in there. So let's go ahead and do that. And we see if you get any errors, you'll see down here any error source. And kind of, this is how it looks like. This is how he's going to execute that on the server. Let me clear that. And then finally, on line 4, Terraform apply and the output that they created in the previous section. So let's go ahead and now we're going to apply that actually on the server. So it's going to actually create now, go to the Okta server, we'll create all the objects, the users, the groups, the authorization server, and OIDC application, all will be created as part of that. And then we will have, at the end, we'll have a token and also a URL that we can then use later on to log in from Kubernetes into Okta. So this is, remember I told you there will be 2 output. So the first one is OIDC client ID. So this is the token that for the application or application. And this is where the issuer, so this is where Kubernetes will need to contact Okta in order to basically users be able to log into Okta. So let's go ahead and copy and paste those information because we need them for next steps. So copy that, put it over here, and I put a note here after we run the Terraform scripts, then note the values for the client ID and URL. That's what I put here. So we need now, next step is to actually inform Kubernetes API server about the new provider, it's Okta. And we need to then modify the API server config file. So let's go ahead and copy that. So these are the things that we need to do. We need to set the this is information that we need to add to the config file, OIDC, issuer URL, and client ID, and username, which is claim, and claims. What kind of claims that it will provide is groups. If you recall, we set the authorization server to return groups as the claims. And we also need this, the URL. So we need then now go to the API server and add this to the config file. So let's go ahead. I open another terminal here and I'm now on the server. I'm not on the client anymore. Let's go ahead and open the API server, and then I can add it somewhere here. Make sure we format that correctly. And then we save it. Note that when we do that, then it restarts the API server. So if you do something like kubectl get pods, you get an error that the connection refused because API server is going through the restart. So we need to wait a couple of minutes in order to before proceeding. Okay, let's try again. And now it successfully restarted. Now it has information about Okta. Let's go back to the script. And then let's copy this again now for the next step. So next step is now to actually be able to connect to the API server, connect the API server to Okta and be able to log in our users. So again, we need to take note of those information. If you're using Linux, you create this as your variables, KS, OIDC client ID, and the URL. For the Windows, if you're using Windows, and I'm using Windows for this demo, we need to do the same thing, create a couple of variables. So and then in PowerShell, you need to put a $ in front of this variable. So let's go ahead and do that. Okay, let's execute that. Now on line 12, so on line 10, before doing anything, we need to install the Kubelogin or OIDC-login, and this is how you install that on your client. So before doing anything else, you need to install Kubelogin, and then once you do that, then on line 12 we can do a test. So we can manually log in. So kubectl OIDC login setup, and then -- OIDC issuer URL. So again, this would be that. And then the client ID would be that. So let's go ahead and do that and see what happens. You'll see that it automatically creates or opens a login page to Okta, and we need to put in the user, one of the users. So let's say Jane. Let's go back and grab the password for her, so we can just do a quick test. We see that authenticated. Now we go back to here. You'll see that it automatically prints out some information. So it tells us what to do next. So it gives us some information about the things that we need to do. First of all, talks about authentication verify, and these are the claims that was returned as part of this exercise. And then we also need to modify the config file to add a user to it. So I already put the information over here. In addition to that, Okta also needs this information. So let's go ahead and run this command. This will modify our config file, which is under .kube config, so that both on Windows and on Linux, that's where the location is. So we need to modify. So run this command, and again, what we are adding is the login and the client ID and the URL. So let's go ahead and do that. So if we go to the config file, you'll see that it added now a section for user. So we have a new user called OIDC. So this is a new user, OIDC. And these are the information, which is what the issuer URL and the client ID that we specified earlier. one thing that we need to do, an extra step, and I noted here, we also need to add this information. These are necessary for Okta login, otherwise you won't be able to log in. And I spent quite a bit of time figuring out that this also needed. So although when it prints out this information, so these are missing. So I guess this is more generic, but Okta also requires this kind of extra scope is email and scope offline access and scope profile, OpenID, all this stuff is also still required. So we need to add that. So make sure that we format this correctly. We won't get any errors. And save it. Now we go back here and then run a command as the new user that we added to a kubectl -- user equal to OIDC, and do a test such as get nodes. Let's go ahead and do that. Once it goes to, we already authenticated, so it's not going to show us the login page again. We come back here, and then you'll see that returns error here because forbidden, because the user Jane Doe does not have enough permission. Right now, our user have no permission at all right now. So when we run a command such as get nodes, especially, we get that error. So in the next step, we will create roles for our new users so they will be able to execute stuff on Kubernetes. So before creating our roles and role bindings, let's go ahead and create our marketing namespace. If you recall, all our users will be operating within this namespace. So on line 2, kubectl create NS, which stands for namespace marketing. Let's go ahead and run that. And that's done. Then we're going to deploy a sample application. We call it Hello World. And so on line 3, kubectl create deployment -n marketing. We call it Hello World -- and this is the image of where the application is coming from. Let's go ahead and that. And then we scale the number of pods to 2. So kubectl scale -- replica is equal to 2 deployment / hello world in the marketing namespace. Okay, now on line 7, let's go ahead and check our deployment. Kubectl get deployment -n marketing. And we'll see that marketing now is created, and we've got both our pods ready. And finally, we create a service. We expose it through node port. So line 8, kubectl expose deployment -marketing hello world and -- port 8080 and target port 8080, and the type is node port. So both the containers and also service are listening on port 8080. So let's go ahead and create it, and that is exposed. Okay, let's now concentrate on our roles and role binding. So the first thing we do is we want to bind the cluster role we created. We call it K8s-admin. So this is the Okta. So this group is created in Okta. So we want to bind this group to a cluster role called cluster-admin. So this is the built-in cluster role that gives those who have access to this, they become the cluster admins. So be careful who you put in that group. And so we're going to call the binding. So the group, the role is already there. We're just binding to that group. So this is the name of our binding. You can name it whatever you want. And this is the kind is role binding. So let's go ahead and run that. So I'm going to run this on the fly. Usually I run everything from Linux, but for this video, because we have to log in from the browser sometimes, it's more convenient to run and record it at the same time. It's convenient to run everything on the Windows client. So that's why you'll see that I'm running this on the fly. So if you're a Linux user, I've created the scripts, the same script, but for Linux and Mac, which doesn't have -Windows name in it. So if your clients, again, you need, wherever you run this, you need to make sure that it has a default browser set up, because that's how a user will be logging in. But anyway, so I've created another one for Linux and Mac users. And in Linux and Mac, there is a here doc concept that you can create document on the fly. The same concept exists in PowerShell. The notation is a little bit different. So anything between ampersand and the quotation and this quotation ampersand, they form our dynamic document that text that you're going to pass to kubectl apply. So basically, you're saying kubectl apply, and then this is the text that you're going to run. So let's go ahead and run that. And we see that it's created. So we have now that binding created. Next, we are going to create now a cluster role. So the kind is cluster role, and the name we call it developer. And then these are the kind of access that we're going to give to this new role. So under resources, API group. So this is the default API groups with nothing in it. So that's the default. And the resources are pods/logs. So the logs within the pods, the endpoint, services, and deployments. So that one set of power or access that they have, the object that they have access to, and the verbs, the operation that they can perform on those are get, watch, list, basically read only on those, but also we'll give them, for the pods, we'll give them get, watch, list, and delete. So this is our developer role. You can create a role rather than cluster role and binding it that way, but the benefit of having cluster roles and having like generic roles such as developer is you can reuse this developer. Then you can bind this cluster role to internally to the namespaces rather than globally. So this is a best practice that I find very useful. So let's go ahead and run this also. So that also was created. And finally, we are going to create a DevOps. So we have some groups that people who will be in the DevOps group. And so again, the role is cluster role. And then here we give them more access or resources, pods, logs within the pods, endpoint services, service secrets, and config maps. And the verbs, these are the operations that I can perform on, or get, create, watch, list, delete, and delete collection. So that was within the default API group. Now within the apps API group, there are other objects that they live, and that one of them is deployment. So for deployment, we'll give them get, list, watch, create, update, delete, and patch. So this would be the role for our DevOps. Let's go ahead and run that. And that's also created. So let's go ahead and clear this. Now that we have our roles created, now next we're going to bind it to our groups that we created in Okta. Okay, on line 2, before doing anything, just double check again to see if the current user or the user we just logged in earlier, that is Jane Doe, has any access to pods in the default namespace. So kubectl --user equal to OIDC and get pods. Let's go ahead and do that. And we'll see that the user doesn't have access to the pods in the default namespace because we haven't given her or her group any access to anything yet. And we can double check that, do the same thing in the marketing namespace on line 3. kubectl -- user OIDC get pods minus n marketing. So we get the same exact error because again we haven't given the groups that she belongs to any access yet or binding to anything yet. So we're going to do another role binding, and this time we're going to do a role binding on K8s marketing -admin. So if you recall, this is the admins for marketing, and Jane Doe is a member of this group. You're going to bind it to another built-in cluster role called admin. So this is not a cluster admin, this is admin. So the admin, the scope of the admin is at the namespace. And we are going to then specify the namespace of marketing. So basically what it means is once we run this group that Jane Doe belongs to will have admin access to the marketing namespace. So the scope is the marketing namespace. So let's go ahead and run this. So that binding was created. Now let's go ahead and test again. So on line 20, kubectl minus dash user OIDC get pods in the default namespace. And the answer is no, because she still doesn't have any access to the default namespace. However, on line 21, kubectl dash user role dash user is equal to OIDC. Again, get pods, and this time within the marketing namespace. And we'll see now that we get results, because now we just gave her access to the marketing, and she has admin access to that. On line 23, we can now actually switch the context from myself. We switched to the user. So kind of in a way, I'm impersonating Jane and Doe again, but this time we kind of permanently, I switched the context. So as long as the context is set to Jane, I don't have to run kubectl dash user equal to OIDC. So kubectl config set it's a context dash current user is equal to OIDC. In this case, the user is Jane Doe. So let's go ahead and run that. So that we'll see that the context was switched. Now, anything command that we are running here on will be in the context of Jane Doe. So I don't have to specify dash user equal to OIDC. So let's do this. So let's say rather than running command, we can also do can I. So on line 24, kubectl auth, can I delete pods in the marketing namespace? Let's go ahead and run that. And the answer is yes, because she has admin access. She's part of the group that has admin access to it. And then on line 25, kubectl auth, can I create secrets in the marketing namespace? So and the answer again is yes. And then on line 26, kubectl auth, can I create roles in the marketing namespace? And the answer is yes. And then on line 27, kubectl auth, can I create cluster roles? So this is now goes beyond her access. Let's see what the answer is. The answer is no, because she is only limited to the marketing namespace. And same thing on line 28, kubectl, can I create namespace? Let's go see. And again, the answer is no, she doesn't have that power. So this is how we can see that we are able to now leverage the groups that we created in Okta. We can now leverage them here. And then we can do the same thing as a developer role. We bind the role we created earlier. We can bind it to the developer role, and in this case would be marketing devs. And the same thing we can do with DevOps. So as you can see, it really shows you the power of having the users manage user groups outside Kubernetes. And in this case, when we have OpenID Connect, it's very convenient because then we can, move people around and things that we couldn't do with certificates, now we are able to do. Now, I leave the other ones as an exercise to you that you can run that on your own. So there's one thing that to watch out. So when the user login such as Jane Doe on a machine, then there's no log off at all. So you have to wait until it's time's out. And the timeout happens quite long. So if you want to try different users, I suggest if you have other machines that you can set up as clients, if you want to run those and then install kubectl on those and then do the exercise, the other exercise you're creating, running as different users and then run on like a different machine. Otherwise, you have to kind of wait maybe a day or so until it logs out eventually, and then you can do the test. So let's recap what we did in this video. We did a lot of work, so let's kind of summarize some of the main points. We discussed limitations with maintaining users and groups when we use certificate as our authentication method, because certificates are not really great for managing users and groups, especially in larger environment where users will be moving around. We discussed OpenID Connect architecture in detail. We then created an Okta Authorization server and Okta users and groups. We then configured the API server configuration file, and we added our Okta Authorization server as an OIDC provider. We then bound Okta groups to existing or new roles. So the existing ones were cluster admins and admins respectively. We also created new roles for our devs and DevOps. And then we also logged in as a specific user, Jane Doe in that case, and we did some testing. So I hope you enjoyed this video. We'll talk to you soon.